Okay, question 11a, we have partial fractions. So, this lovely looking thing here, 1 add 11x minus 6x squared over x minus 3 times 1 minus 2x can be written as a add b over x minus 3 add c over 1 minus 2x. Part A, for 4 marks, wants us to work out the values of A, B and C. So, what we need to do is turn these 3 terms on the right into a single term, so a single fraction. We'll end up with the same denominator as the left hand side, and we're going to compare terms on the top. So, let's do it 2 at a time. So let's do A add B over x minus 3. First, so A add B over x minus 3. Well, we can think of that as using common denominators, A times x minus 3 over x minus 3 add b over x minus 3. So that is going to give us ax add minus 3a add b all over x minus 3. Okay, now we're going to do that times the fraction with c. So we're going to do ax minus 3a add b over x minus 3 add c over 1 minus 2x. Okay, so going for common denominators, we're going to need to multiply this chap by 1 minus 2x. On the top and bottom. And then we're going to need to multiply this chap by x minus 3. Okay, so now that we have the common denominators, all that we need to worry about is the top. So we're going to expand and simplify the top, and then compare it to 1 add 11x minus 6x squared. So, let's get rid of the bottom. So we got ax minus 3a add b times 1 minus 2x add c times x minus 3. We know that that is identical to 1 add 11x minus 6x squared. Okay, so let's expand. So ax times 1 is going to give us ax. Ax times minus 2x is going to give us minus 2 2ax squared minus 3a times 1 is going to give us minus 3a minus 3a times minus 2 is going to give us plus 6ax. Then we got b times 1, so that's b. And then b times minus 2x gives us minus 2bx. Then we got c times x, which is cx. And then c times minus 3 gives us minus 3c. Okay, so that, again, is identical to 1 add 11x minus 6x squared. Right. Now then, let's go through and order this a bit nicer. So, we've only got 1x squared term. So we got minus 2ax squared. At this point, we could work out what a is. A is 3, but I'm gonna reorder the stuff on the left first of all, and then worry about the letters. So, that's that term gone. Now let's do all of the x's. So we got ax. So, you're gone. We've got plus 6ax. So, you're gone. We've got minus 2bx. You're gone. And we've got plus cx. Okay, so you're gone. Just check there's no more x's. Nope. Okay, so now the constants. So we got minus 3a. So you're gone. We got add b. And we've got minus 3c. You're gone. Obviously, in your real thing, don't cross out the terms. Maybe put a little mark above each one as they're gone. If you cross them out, your marker can't read them. Okay, so again is identical to 1 add 11x minus 6x squared. Right. Okay, so now then we can start working out coefficients. So we've only got 1x squared term, and we got 1x squared term over here. So we know minus 2a has to be minus 6. Therefore, a is equal to 3. Cool. Okay, now let's do the x terms. So, we know that a add 6a, so that's 7a. So 7a minus 2b add c is equal to 11. Now we know that A is 3, so 21 minus 2B, and C is 11, so 2B minus 2B, and C is minus 10. Okay, so we can't do anything else with that yet. Let's now go through the constants. So, constant-wise we've got, didn't put a line under that. Okay, constant-wise then, we got minus 3a, add b minus 3c. So, minus 3a, add b minus 3c. Then we know that that has to equal 1. So, we know that A is 3, so we get 9, minus 9, add B minus 3C is equal to 1. So, if we add 9, B minus 3C is equal to 10. Okay, so we now have simultaneous equations. So we know that minus 2b add c is minus 10. And we know that b minus 3c is positive 10. Okay, so let's call them 1 and 2. So we got simultaneous equations. I'm going to go for eliminating c. So I'm going to multiply equation 1 by 3. So I'm going to get minus 6b add 3c is minus 30. Call that equation 3. Now, if we add 2 and 3 together, we're going to get b add minus 6b, so minus 5b minus 3c, add 3c cancels out, that's the whole point. 10 add minus 30 is minus 20. So minus 5b is minus 20, b is 4, and then we need to work out c. So if b is 4, we know that minus 2 times 4 and c is minus 10. So we get minus 8 and c is minus 10. So c is minus 2. So we've done it. A is 3, B is 4, C is minus 2. Cool. Then for part B, f of x is the function 1 and 11x minus 6x squared over x minus 3 times 1 minus 2x for x greater than 3. We want to prove that f of x is a decreasing function. So, decreasing functions are ones where the gradient is always 0. So, we're going to need to differentiate f of x. Now, you can see why we did partial fractions in part A, because we definitely do not want to differentiate it in its original form. We could, but we don't want to. So, we now know then, thanks to our partial fractions adventure, that f of x can be written as 3 add 4 over x minus 3 minus 2 over 1 minus 2x. So, we should probably make a statement. So, if f of x is a decreasing function, then f dash of x is less than 0 for all, or well, it won't be for all, it will be for all x greater than 3, because we were told that was the domain of the function. Okay, so let's differentiate then. So f dash of x, or let's rewrite f first. So f of x is 3 add 4 x minus 3 to the minus 1 minus 2 1 minus 2x to the minus 1. Okay, and then the derivative. So 3 disappears. 4 x minus 3 to the minus 1. Well, using the chain rule, if we differentiate x minus 3, we just get 1. So that's good. The power of minus 1 comes down, multiplies to 4. So we get minus 4 times x minus 3 to the minus 2. And then we're going to get, so by the chain rule here, 1 minus 2x differentiates to minus 2. So we got our minus already, and we're going to get minus 2. Now, the power of minus 1 comes down and multiplies the 2 at the start. So that's going to give us another negative. So remember what's happened, I've already put this negative here. So when the minus 1 comes down, it's multiplying a positive 2. So that's going to be times 1 minus 2x to the minus 2. Right, so we can write this as minus 4 over x minus 3 squared minus, well, is it going to be a minus? So we got minus 2 times minus 2, which is positive 4, and then we got the minus on the outside. So that's going to give us minus 4 over 1 minus 2x squared. Now, we could say that that is minus 4 times 1 over x minus 3 squared, add 1 over 1 minus 2x squared. Now, for x greater than 3, 1 over x minus 3 squared, add 1 over 1 minus 2x squared is always going to be greater than 0. Therefore, f dash of x, which is minus 4 times that bracket, is always going to be less than 0. So, f of x is a decreasing function